What's going on, everybody? Welcome to our interview series. In this tutorial we are going to solve a problem asked by Google, and this problem contains a data structure binary tree, and it's actually a pretty simple problem. However, it can be a little bit of hard to think because it contains recursion or weird while loops. So the problem statement goes like this. You are given an initial binary tree and they ask you if it's symmetric or not. So if it is symmetric, we are going to return true from there. If it's not, we are going to return false. It's nice and simple, right? So let's look at that example and let's try to understand what symmetric means here. So if you look at the binary tree here, this solution returns true, and the symmetry actually goes like this. So you draw a line from the root of the binary tree till the end, so it's actually need to be symmetric on the y-axis, and you compare the left half with the right half. So as you can see, 2, 2, 3 and 3, 4 and 4. But remember that this binary tree's nodes must be reversed. So left half, if you reverse all the left half nodes, you need to achieve the right subtrees nodes. Actually, problem is just simple like this, but how to solve it? You can solve it with while loops, or I've even seen for loops too. However, I prefer to solve data structures with recursion, because you don't know the endpoint, and recursion works pretty well on both binary tree, linked list, etc. So let's try to solve it now. So here on my editor, I've created a simple class of a binary tree. It holds three values. One is an integer, just holds the value of the node, and the other ones are the left and right child nodes. So in the constructor, I've just assigned left and right to null pointer as in code signal, and assigned the value to integer value. So in here I have two simple binary trees. I've written this for you. So let's look at the first one now. As you can see, if you draw a line from here and compare this part with this part, you can see that this binary tree is symmetric. So, but how will we deal with the null pointers here? We'll see. I'm not giving you the answer yet. And if you look at the bottom one, if you draw a line from here, as you can see, this is not symmetric, because if left child's right child is 3, then on the right subtree, this 3 needed to be on the left part. So this is not a symmetric binary tree. But how to solve this problem? So let's write our function first. So I'll call this bool is symmetric. This function will contain two node values, and both of them will be the reference of root node. So to compare the left half with right half, we need actually two parameters, but these two parameters will actually be the same. So 3 pointer, let's call this left for left subtree, and the other one right for right subtree. In initial state, these both left and right subtrees are equal to root node, okay? So as you might know, all recursive functions need to have a base condition. So what will be our base condition here? So actually, if you look at the tree I drew here, and if you see these two nulls, so if both of them are null pointers, we know that this tree is symmetric and we need to return true from there. So we are going to compare it with AND operators, okay? So if left tree equals to null pointer and right tree equals to null pointer, we are going to return true. So why is that? This is why I drew this. As you can see, in this left subtree, the leftmost point is null, and in this right subtree, rightmost point is null. So if we are going to check if either is null or not, therefore we know that this binary tree satisfies our condition, so we return true from there. However, if one pointer is null, so assume that left half pointer is null, but right half contains a value. So I just deleted this null, and for example, I've put 5 here. So in the compare function, one is null pointer, but the other is not. Therefore, we know that it is not a binary tree. I'm sorry, symmetric binary tree. Therefore, we need to return false. So our next condition will be if L equals to null pointer or R equals to null pointer. If this situation occurs, we know that this is not a symmetric binary tree, so we are going to return false from here. So now for the cool part, we can write this in just one simple line actually. It's actually a pretty simple question, but kind of hard to think of its logic. So let's write it now. If our L node's value equals to right node's value. So we need to compare these two functions. As far as we know, since we are going to chain it like this, if they are not equal to one another, this function is just going to return false. And if they are equal, it will just return true. However, we are not done yet. We are going to do our recursion in our return function too. Return command too. So we need to chain it with AND. Because if any one node is not equals to other node, then all of them needs to be returning 0. Therefore, to be able to do that, we need to chain all our commands with our AND operator, okay? If you use OR, you'll get wrong answer. So AND. So let's think about it. If we are going to compare the left subtree with the right subtree, and if we need to know that if it is symmetric or not, its logic is actually pretty simple. So let's take these two cases here. So I'm in the second one here. So I've traversed the first node to left and the other one to right. So how to traverse this? So if I am going to traverse left subtree to left, then I need to compare the right subtree with right. And again, if I am comparing left subtree with the right node, then I need to compare our right subtree with the left node. So it's actually the opposite. It's pretty simple. So if our recursion steps containing left to the left subtree, then we need to do the opposite on the other one. Pretty simple, right? So I'm calling our function again for recursion. I'm traversing left subtree to left, and I'll traverse right to right. Opposites. So I need to call it again, but this time I'll just do the opposite. So I'm traversing left subtree to right and right subtree to left. Alright, cool. So let's try this function now. I'm calling is symmetric here, and I'll just give, as you know, two roots there. And let's call this function again and give root 2 here. So when we run our code, first need to return 1 and the other one needs to return 0. As you can see, we have successfully returned 1 and 0. So alright, so let's implement this in code signal now. I'm just copying this function here and returning the code signal, and I'll just paste it here. So let's do it. So in code signal they write a template for these trees, therefore you need to surround them with these smaller and greater signs, and actually I think this is it. So in the bool solution, I'll just return is symmetric with t and a t again. So if you just know a little bit of recursion, you can solve this problem, I think, but it's like magic because we did it in like 6 or 7 lines. However, everyone's functions are pretty similar. You can check from here. Actually, all of them are pretty the same. So this is just it. So you can look at a different implementation here. This guy solved it with stack. However, if you solve it with stack, I think in a high-tech company interview, they don't want you to do this. I think they want you to do this on O1 space, so not using extra memory, and order of n time complexity. Therefore, you need to use the recursive method to be able to solve this function in the interviews. Alright guys, so see you in the next tutorial. Take care. By the way, if you have any interview problems that you couldn't solve, just link them in the comments and I'll try to solve them. If I like it, I'm going to make a video of it. So take care guys.